Okay, we're going to work some force problems. Our formula as we work force is F is equal to ma. F stands for force, and we're going to use the unit of newtons for force. It's a capital N. This is a little m. Little m stands for mass. And when we work these problems, our mass needs to be in kilograms. A is acceleration, and acceleration for us needs to be put into meters per second squared. The other way that you could write this, and it's how it appears on our North Carolina reference tables, is meters per second per second. It's the same difference. So as we get ready to work the problems, we need to keep in mind that this is our equation, and these are the things that we need to use. Now, if you're watching along from home and you haven't done this in class, then you can pause it and you can write these things down. Our first equation that we're going to work, or our first problem, is up here at the top of the screen. It says how much force is needed to accelerate a 1,000 kilogram car at a rate of 3 meters per second squared. Well, usually what I do in class is I write on the problems, and I don't have that ability right now on my screen, but I can make a list right here where I know that mass of the car is 1,000 kilograms. And I know that for the reason that right here it uses kilograms. And kilograms, I know from our list that we just made, that kilograms measures mass. So that 1,000 is a unit of mass. And then I have this. I've got 3 meters per second squared. Well, I know that the unit of meter per second squared is the unit of acceleration, so that's our A. And then it says how much force. So that's the question that I'm finding. And I actually got rid of this when we did it in class. So we're just simply answering right here how much force. So we are finding F. That's what we want to know. Well, this is going to go straight into our equation. F is equal to ma. F right over here says that's what I want to know. So I'm just going to write the F down again because I don't know a number for it. I'm wanting to solve for it. My M is 1,000, so I'm going to substitute 1,000 kilograms in. And then my A we have on a list is 3 meters per second squared. So if I sub those things in, I'm now ready to solve for F. Once I multiply, I've got 1,000 times 3 is 3,000. The unit of force is Newton. That's what we're going to put in there. 3,000 newtons. And that answers my question. 3,000 newtons is needed to accelerate a 1,000 kilogram car at a rate of 3 meters per second squared. Have another problem. It says if a 70 kilogram swimmer pushes off the pool wall with this force, what is her acceleration? Well, again, kg, I know that I have this number here. I know that I have 70 kilograms in my problem. And I know that kilograms measures mass, so that's an M. And it says that they push off with a force. It tells me the word force, and it says a force of 250 newtons. So I know it's a force because it says the word force right here, but it also uses the unit of Newton. So for two reasons do I know that that is an F. So I've listed that. The question is, what is her acceleration? So in my paper, I put A equals a question mark, because that's what it's wanting me to find. I have everything that I need to once again plug into F is equal to ma. And I'm going to do the same thing I did last time. I'm going to come over here and I'm going to plug into the equation. So my F, I do have a number for this time. So I'm going to substitute 250 instead of F. I have an M, so I'm going to substitute in 70 kilograms for my M. And my A, I don't have a number for that. So I'm going to put A again. Well, now at this point it becomes a math issue. How I solve for A is I need to get rid of 70 kilograms, which means I need to divide both sides by 70 kilograms. And I know that because I'm multiplying by 70 kilograms on the right side, and in order to get rid of it, I need to do the opposite. So over here, those are going to cancel out. So to find A, I'll need to take my calculator, and I'll need to divide 250 by 70. And I'm asking my classes to round to like a decimal place. My calculator says 3.571. I mean, I would take that as an answer in class. If you want to round it though, then you would have to say 3.6. I wouldn't accept it if you said 3.5, because if I keep the 5, the 7 next door says the 6 should round up. We'll skip a couple of questions here. Actually, no, we're going to do this one. I realize now it meets my needs. When I'm asked about weight, one of the things that we should know is that force is equal to weight. Because when you stand on a scale, the force of gravity is pulling you down, and gravity has an acceleration of 9.8 meters per second squared for gravity. Now, some people will rewrite it as F sub g is equal to m times g. What they mean by that is that this is weight. What they mean is force of gravity. This is still mass, and g is acceleration due to gravity. And we just said acceleration due to gravity is 9.8 meters per second squared. Mass still has to be in kilograms, and weight will still be in newtons. So, for example then, this problem that's up above, if we work it this way, it says find the mass of a football player. Well, right off it's wanting me to find the mass of a football player who weighs 1,250 newtons. I can either just put this in as force, because newtons is force, or I could write F sub g. It really doesn't matter to me. I personally just use the regular old force for everything, because why not? You know, it doesn't make a difference. I've seen some places where they'll do this as W. It just so happens that for our reference tables, if we look at those, I know this is kind of small, I don't have a W as weight. It just simply has FG as weight. So we're just going to plug it right into that. So you can use either F is equal to MA or FG is equal to MG. If I use F is equal to MA, his weight is 1,250 newtons, and the mass I don't know. His acceleration is going to be the acceleration due to gravity. If I plug it into this one, we'll see if I have enough room here, it's going to look exactly the same. His weight is 1,250, his mass I don't know, and G is 9.8. Like, there's absolutely no difference between the two formulas. In either one of them, I need to get m by itself, and how I do that is I divide both sides by 9.8. It'll be the same thing over here. There is absolutely no difference. 9.8s will cancel, and for both of them, this guy, or this, I guess it could be a girl football player, you know, this person will have a mass of 127.6 kilograms. And how I know it's kilograms is I just simply have to memorize that mass will be measured in kilograms. Now, I have one more on here which says what is the weight of a 100, no, just kidding. I don't know where I'm coming up with that. What is the weight of a 40 kilogram person? Well, as soon as it says weight, that's FG or F. That's what it wants me to find. And I know that mass is kilograms, so this person has a mass of 40 kilograms. What I'm missing is acceleration, or G, and for us that's going to be 9.8 meters per second squared, because that's the acceleration due to gravity. So F is equal to m times A. This person is going to have 40 kilograms times 9.8 meters per second squared. If I can type, I don't have these done in front of me. This person would have a weight of 392 newtons. So that would be the answer to my question, regardless of which formula I put it into. So keep in mind that you can work it either way, like we did up here, whatever makes you more comfortable, and we should get the same answer.